Question: write canonical form of del square z by del x square minus del square z by del y square equal to 0. Okay. Now rewriting the given equation, we can write it as capital R, capital S, small s, capital T, small t, f, x, y, z, p, q. Okay. This is PDE of second order. Here, what is R? R is del square z upon del x square, small s is del square z upon del x del y, and small t is del square z upon del y square. Now, you can see R, capital R is coefficient of del square z by del x square, this is 1, and capital S is 0, and capital T, you can see capital T is minus 1. Now, applying formula s square minus 4rt. This is the formula by which we can get that this equations is parabolic or elliptical or hyperbolic. Okay. 0 minus 4, r is 1 and t is minus 1. This is plus 4. Okay. So, this is hyperbolic. If s square minus 4rt is greater than 0, then this is hyperbolic. Okay. When s square minus 4rt equal to 0, then it will be parabolic if s square minus 4rt will be equal to 0. So, in this condition, you can see s square minus 4rt is plus 4, which is greater than 0. So, this equation is hyperbolic. Now, the lambda quadratic equation. Now, we write lambda quadratic equation. This is r lambda square s lambda plus t. Okay. Where r is 1, this is lambda square, s is 0, 0 lambda plus t is minus 1. Now you can see lambda square minus 1 equal to 0. This is lambda equal to 1 and minus 1. If lambda 1 equal to 1, lambda 2 equal to minus 1, then dy by dx. Okay. You can see lambda 1 equal to 1, lambda 2 equal to minus 1. You can see dy by dx plus lambda 1. And again we can write dy by dx plus lambda 2 equal to 0. Now, first one is dy by dx plus 1 equal to 0. And second is dy by dx minus 1 equal to 0. Now, we can integrate it. This will become y plus x equal to c1. And this will be y minus x equal to c2. Okay. Now, first equation we write u equal to y plus x. Okay. And v equal to y. What we are doing? We are doing canonical form of partial differential equation of second order. Okay. This is of hyperbolic type equation. Now, first we need to find p. What is p? Del z upon del x. Now we can write del z upon del x as del z upon del u to del u by del x plus del z upon del v upon del x. This is del z upon del u upon del x is 1, del z upon del v, and del v upon del x is minus 1. Del z upon del u minus del z upon del v. Okay. Now, similarly, we can find q. Q is del z upon del y. Okay. What is q? We can write del z upon del u upon del y, and similarly del z upon del v and del v upon del y. Okay. You can see del z upon del u is del z upon del u, and del v upon del y is 1, and del z upon del v and del v upon del y is 1. Okay. Now, we can write q del z upon del y equal to del z upon del u plus del z upon del v. Now, from this equation and this equation, we can get del upon del x equal to del upon del u minus del upon del v. We can write it as, and similarly del upon del y we can write del upon del u plus del upon del v. We can write it as. Okay. Now, what we need to find del square z upon del x square. This is, r, small r, del square z upon del x square. And this will be del upon del x or del z upon del x. You can see del upon del x is del upon del u minus del upon del v. And this is del z upon del x is del z upon del u minus del z upon del v. Now, you can multiply it del upon del u, and this is del z upon del u minus del z upon del v minus del upon del v, del z upon del u minus del z upon del v. Okay. This is del square z upon del u square minus del square z upon del u del v minus del square z upon del u del v, and this is del square z upon del v square. Del square z upon del u square minus 2 del square z upon 2 del u del v plus del square z upon del v square. Okay, this is your value of small r. Now we need to find del t. What is t? Del square z upon del y square. You can see in the question del square is u here. You can see del square z upon del y square. Okay, and this will be del upon del y and del z upon del y. What is del upon del y? Del upon del u plus del upon del v. You can see here. Okay, and del z upon del y is del z upon del u plus del z upon del v. Okay, now this is del upon del u, del z upon del u, del z upon del v, del upon del v, del z upon del u plus del z upon del v. Okay, and this is del square z upon del u square, del square z upon del u del v, del square z upon del u del v, and del square z upon del v square. Okay, this is del square z upon del u square, and it is 2 del square z upon del u del v. This is del square z upon del v square. Now original equation is which equation we want to convert in canonical form. This is del square z upon del y square equal to 0. Now putting the value of del square z upon del x square, and this is del square z upon del x square is del square z upon del u square minus 2 del square z upon del u del v, and this is, you can see, this is del square z upon del v square, and similarly minus del square z upon del y square is del square z upon del, this is u square plus 2 del square z upon del u del v, and this is del square z upon del v square equal to 0. Now solve it. You can see del square z upon del u square minus 2 del square z upon del u del v plus del square z upon del v square, and again this is minus del square z upon del u square minus 2 del square z upon del u del v minus del square z upon del v square. You can see now it is 4 del square z del u del v equal to 0. You can see del square z del u del v equal to 0. This is canonical form. I think it is you understand this question. Thank you.